Hey everyone, we're going to graph the rational function f of x here. This is an introductory video and we're going to do this based off asymptotes. We know that a rational function has two or more branches and they approach lines called asymptotes. So what we have to do is find our vertical and horizontal asymptote and then just pick a few key points to get a general form of what it looks like. Usually rational functions look something like this. These are the branches, the ends of the asymptote that approach the asymptotes. So it looks like that, or you could have something like this. There's some more creative ones that have more than two branches. So let's look at this. The vertical asymptote's pretty easy. It just makes it where the function is undefined. So we don't want our denominator to be 0 because that would be undefined. So we solve for x, we get x cannot be 3. So that's your vertical asymptote because the graph can never cross this x equals 3 line. So that's your vertical asymptote. Your horizontal asymptote is more conceptual. And basically what it means, it's the line where the function y approaches to as the value of x increases. So basically if I put y equals, and I'm going to put 100 in for x. So I'll get 200 plus 1 divided by 100 minus 3. That's going to give you 201 divided by 97. That's very close to 2. And that's what you're looking for, is this approximation. Now they want as the value increases, so let me illustrate that. If you have bigger numbers, so 2 million. So I'm going to put 1 million in. So you get 2 million and 1. And then this would be 1 million minus 3. So 1 million for this x, 1 million minus 3 would be what? 999,997. This is almost 1 million, and this is close to 2 million. So this is even closer to 2. So that's what the horizontal asymptote means. That means y is going to get closer and closer to 2, but it'll never equal 2. It can't because of the nature of the problem, but it won't cross the horizontal asymptote. So basically your horizontal asymptote, therefore, is y equals 2. Now these asymptotes are going to frame how we graph. So let's do our asymptotes. The vertical asymptote is x, whoops, let me get this. Oh my goodness. All right. X equals 3. So that's your vertical. This vertical line, you know, it's not a function. X equals 3. And your horizontal asymptote is y equals 2. All right. So basically we know, like I said before, it should look something like that. So what we want to do is pick, like, say, a 4. Let's see what 4 goes to, because I don't know if it's in which part of this new quadrant we have it falls in. So if I plug in 4 into this, I'm going to get 9 divided by 1. So that goes to 9. So I'll go from 4 goes to 9. Right? Yeah. 8 plus 1. So if I plug in 4, I'm going to get 9 divided by 1. Okay, I just want to make sure. So that's way up here. If I plug in 5, I'm going to get 11 divided by 2, which is 6.5. No, it's going to be 5.5. So we'll just go up 5.5. So something like this. Now you can plug in another number, say down in here, and what's going to happen, it's going to look like this. You just need to plug in about 3 numbers. But let your asymptotes guide you and the fact that you know what this looks like. All right, now we should have another part, so I want to get on this side. So I want to plug in 2. If I plug in 2, I'm going to get 2 times 2, that's 5, negative 1. So that's negative 5. So this is 1, 2, this is 2. 1, 2, 3, 4, 5. So it looks like this. And if I plug in 1, that's going to be 2 plus 1 is 3. And 1 minus 2 is, 1 minus 3 is negative 2. So that's going to be negative 1.5. So right about there. And let's go ahead and plug in 0 and see what happens. That's going to be easy. If I plug in 0, I get 1 over negative 3. So if I plug in 0, that's negative 1/3. And so you just plot some key points, and it should be reflect over this in this new origin we have. So basically graph it like that. Sometimes it's a good idea to pick a number out in here, a negative number there, if you want to get a more accurate graph. And that's it. Thank you. Have a nice day. Bye-bye.